We have a series circuit having 3 resistors and a voltage supply of 48 volts in DC. 3 resistors, R1 is 2.20 kilo ohms, R2 is 3.30 kilo ohms, R3 is 1.50 kilo ohms. We need to determine the total resistance, the current flowing through the circuit or the total current, the voltage drop for the 3 resistors, and verify Kirchhoff's voltage law. Okay? The first step is to convert the values of the resistors. Now, let's convert first R1. As you can see, R1 is 2.20 kilo ohms, right? 2.20 kilo ohms. So, 2.20 kilo ohms, K is 1,000. Okay, so that would become in ohms, right? We convert kilo ohms into ohms. That is equivalent to 2,200 ohms. Okay, now for the R2, there is 3.30 kilo ohms, right? You convert that first to ohms, that would result to 3,300 ohms. Okay, how about 1.50 kilo ohms? If we convert that into ohms, K is thousands, right? That is 1,500 ohms already. Okay, so we write this one here. We have converted the resistors, right? 3 of them. Now we need to take the total resistance of the circuit. We need to calculate the total resistance of the circuit. How do we do that? Since it is in series circuit, we do this way. This is how we do it, okay? So R total, RT for short, is equals to R1 add to R2, then you need to add it to R3, right? R total or RT is equals to the value of R1 is 2,200 ohms plus R2, value of R2 is 3,300 ohms plus R3, the value of R3 is 1,500 ohms. Okay, saan ang galing yun? Saan ang galing yun? Where does those values came from? Okay, yan. Yun, no? Okay, right? Correct? Okay. Now, R total is equals to, when you add those, it will give you how many? 7,000 ohms. Edi meron na tayong total resistance of the circuit. Yes? Now, we are going to compute for the circuit's total current. Okay? Total current of the circuit. So how do we find the total current of the circuit? As you can see, there is a purple triangle there at the upper right of the screen. Yes? Okay. When we find the current I, okay, say we take out that one, what remains is the voltage and the resistance. Tama? So that would be current is equals to the voltage divided by the resistance of the circuit. Yes? Okay, so sulat natin, no? So, I total That is what they want us to find. I total is equals to voltage total, okay, over the total resistance. And the total resistance of the circuit is 7,000, right? R total. Okay. I total is equals to 48 volts DC over the total resistance of the circuit, which is 7,000 ohms. I total, okay, or IT, what do we do about it? We divide these two, division, okay? So when we divide 48 volts DC to 7,000 ohms rather, we get 0.0068574. Medyo madami, no? Amperes. Okay? So now we have total current. Now we are going to solve for voltage drop for R1. R1 muna. R1 first. Resistor 1. Voltage drop. So, how do we go about it? Okay, so we write VR1 or voltage drop across R1. That is a shortcut, VR1. Okay? VR1, the formula for that, based on our purple triangle there, when you try to find the voltage, you need to multiply the current to the resistance. Okay? So that will equate to, it will show total current multiply to R1. Okay? O, kasi R1 yung nahanap natin eh. We are looking for R1, right? Okay? VR1 is equals to the value of the current, that is 0.0068574 amperes. Okay? Multiply it to the value of R1, which is 2,200 ohms. Sir, saan nakuha ang 2,200 ohms? If you may ask. Okay? Ito yun siya. Ayun. That one, ayun. Okay? Oh, next, we write VR1, voltage drop across R1. Okay? Multiply these two. You multiply these two. Okay? Dalawa na yan. You multiply, ano? Okay? And what you get is 15.085. So we write 15.085 volts. Voltage is equals to current multiply via the resistance. But in this case, we write voltage drop for R2, okay, is equals to the total current of the circuit, I total, right? Multiply it to, ano yung hinahanap natin? What we are looking for is R2, right? Now, VR2 is equals to the value of the total current of the circuit is 0.0068574 amperes. A na lang. Multiply to R2, and the value of R2 is 3,300 100 ohms. Voltage drop across R2, okay, is equals to, we multiply again these two values. Oh, multiply yan, ha? Multiply, okay? We multiply them. And let's just erase. Okay? So when you multiply those, the current and the resistance, you get 22.628 volts. Oh, now we have two voltage drops already, right? We have voltage drop R2. We are now going to compute for voltage drop R3. Okay? So following the same formula here, this one, we'll check, right? We write voltage drop R3, right? It's a bit long, right? It's a bit long to write, so let's do a shortcut. It's much easier. We write instead VR3, voltage drop for the third resistor. Okay? So VR3, or voltage drop for R3, is equals to the total current of the circuit, right? I total, multiply it through R3. Okay, now voltage drop for resistor number 3 is equals to the total current value, which is 0.0068571 amperes, multiply to the value of R3, which is 1,500 ohms, right? There it is. Okay. We write again, voltage drop for R3 is equals to, okay, these values, we multiply them, right? We multiply them, those values. Okay. So what do we get? When we multiply those two, we get 10.285 volts. Yun. Now we have a voltage drop for the third resistor. Okay, we write now there 10.285 volts. Kompleto na. Now it's complete, right? The last step for the problem solving is that we need to verify Kirchhoff's voltage law. Ayan, I will underline it. There it is, right? Verify, right? We need to verify. So how do we do that? Okay, we write the supply voltage, okay, which is 48 volts DC, right? Okay, positive, right? Then we subtract voltage drop for the R1, which is 15.085 volts, okay? Then we subtract again 22.628 volts, and then we subtract again 10.285 volts, and then what we get out of those is 0. Alright? Satisfying the equation, the algebraic sum of voltages in a closed loop circuit is equals to 0. Okay siya, no? Or you can double check by verifying Kirchhoff's voltage law. You can also do this, okay? You can also do this. 48 volts DC is equals to 15.085 volts add it to 22.628 volts, okay, and then add again to 10.285 volts, and you get 48 volts DC. Alright? Until the next video, guys.